Hello everyone and welcome to our programming series. In today's video, we are going to dive into the fascinating world of data structure. Specifically, we will be exploring one of the fundamental data structures, the queue. So grab your favorite coding tool and let's get started. Introducing the queue, a powerful tool used in computer science and programming. Just like in real life queues, where people wait in lines for their turn, a queue data structure follows the same principle. The first element to enter is the first to exit. Imagine you have a line of tasks or data elements waiting for their turn to be processed. A queue ensures fairness and maintains the order of arrival, ensuring that every element gets its fair share of attention. But how does a queue work behind the scene? Well, we will see in upcoming slides. So our today's agenda is introduction to the queues, definition and purpose, the important FIFO, first in first out principle, implementation of queue in Python, applications of queue, the advantages and disadvantages of queue, use cases and applications. Starting with the introduction, a queue is a fundamental data structure used in computer science and programming. It follows the FIFO, first in first out principle, where the first element added is the first one to be removed. Queue provides a way to store and manage the data in specific order, allowing efficient operations such as enqueue, dequeue, and pick. We have a definition of queue. A queue is an abstract data type that represents a collection of elements with two main operations, enqueue and dequeue. Purpose of queue is queues are used to handle data in first out manner, making them suitable for specific applications such as process scheduling, BFS, that is breadth first search algorithm, and many more. Now the most important first in first out principle, FIFO principle. In a queue, the element that is inserted first is the first one to be removed. New elements are added at the rear of the queue and removal happens at the front. You can visualize a queue of people standing in a line of movie tickets. So you can take that example and read this sentence again. You will clear with FIFO principle. Now we have implementation of queue in Python. Basically, there are multiple ways to implement a queue in Python, which is using a list, using collection.dequeue, and using queue.queue module. Implementing using list. So list is a Python's built-in data structure that can be used as queue. Instead of enqueue and dequeue, append and pop function is used. However, lists are quite slow for this purpose because inserting or deleting an element at the beginning requires shifting all of the other elements by one, requiring order of n time. So let's see implementation of queue using the collection.dequeue. So queue in Python can be implemented using dequeue class from the collection modules. Dequeue is preferred over list in the cases where we need to quicker append and pop operations from both the ends of the containers, as dequeue provides an order of one time complexity for append and pop operation as compared to the list, which provides order of n time complexity. Instead of enqueue and dequeue, append and pop left functions are used. Now the last implementation is using queue.queue. Queue is a built-in module of Python which is used to implement a queue. Queue.queue in bracket we have to pass the max size. Initializes a variable to a maximum size of max size. A max size of 0 means a infinite queue. These queues follow also FIFO rule. So summarizing all this, in Python there are multiple ways to implement. Okay, the list implementation uses append and pop functions, but it can be slower for large queues due to shifting of elements. The collection.dequeue implementation is preferred for its efficient append and pop left operations with a time complexity of order of 1. The queue.queue module provides a built-in implementation of a queue following the FIFO rule with the option to set a maximum size. These implementations offers different trade-offs in terms of performance and functionality. Creating a queue class. To create a queue class in Python, we can utilize the built-in collection.dequeue model. Okay, so class queue, we have init self. So the class queue has three main methods: enqueue, dequeue, and isEmpty. The queue is implemented using a list where the front of the queue is represented by the first element and the rear of the queue is represented by the last element. Now we have enqueue function which append the item in our items uh, list. Okay. In the dequeue, we have if not self dot isEmpty, we can pop that item. IsEmpty function return is the queue is empty or not. The code snippet demonstrate enqueue and dequeue operations. Elements can be added to the rear of the queue using the enqueue method, and the dequeue method removes and returns the element from the front of the queue. In the given example, we enqueue three elements, that is 10, 20, and 30. Okay. Then dequeue two elements. So first dequeue we get output as 10. Second dequeue we get output as 20. We can check queue.is underscore empty function, but there is 30 which is element present in queue, so it gives us a false. If we again dequeue the queue, it gives output as 30, and if then we pass queue.is underscore empty, it will give true as queue is empty. So in queue, front and rear pointers are used to keep track of the first and last element respectively. The front pointer points to the first element while the rear pointer points to the last element. As the elements are enqueued and dequeued, these pointers are updated accordingly. So visualize the front and rear pointers with a diagram showing their positions in a queue. Now talking about the applications of queue applications. First one is BFS, breadth first search algorithm. The BFS algorithm uses a queue to traverse graphs in breadth first manner. S- Starting from a given node, the algorithm explores all its neighbors before moving to the next level of nodes. By using a queue to store the nodes, the BFS algorithm ensures that nodes are visited in order they were encountered. Following the FIFO principle, this approach guarantees that the shortest path to each node is found. Visualize the traversal of a graph using BFS algorithm with a diagram showcasing the queue-based exploration. Printers and operating system scheduling is another application of queue. Queues finds applications in managing printer tasks and scheduling processes in OS. In the context of printers, tasks are added to a queue and the printer process them in the order or they were received. So this ensures fairness in printing and prevents resource conflicts. Similarly, OS utilized queues to schedule the processes, ensuring that each process gets its turn to execute. By using a queue-based approach, fairness and efficiency in task execution are achieved. Include a okay. So there are some advantages of queue in this scenario. First one is order preservation. Queues maintains the order in which elements are added, ensuring that the first element is always the first one to be processed. Efficient operations. NQ and DQ operations have a time complexity of order of 1, providing efficient access to both ends of the queue. Flexible sizes. Queues can dynamically resize to accommodate new elements, avoiding overflow and underflow issues. There is one disadvantages of queue. What is it? The limited access. Queues do not provide direct access to the elements in the middle, requiring sequential travel to reach a specific element. There are some use cases of queue and applications. So, task scheduling in operating system, message queues in distributed systems for inter-process communication, implementing caching mechanism in web servers. These are some use cases of queues. Breadth first search (BFS) algorithm for graph traversal. We can use queue, simulating real life scenarios such as waiting lines in banks or supermarket or movie theater, anything. Handling incoming network request in web applications. So there you have it, an introduction to the mighty queue. We have explored its purpose, implementation in Python, real life applications with some advantages, disadvantages, and use case. With queues in your programming arsenal, you will have the power to organize and process the data efficiently. Thank you for joining us today. So make sure to like this video and subscribe to our channel for more exciting programming content. Until next time, happy coding.